I want to call your minds back to when we redefined trigonometry and we said all the trig functions, they start in triangles, but let's move away from triangles where you're stuck on acute angles, and let's move to the unit circle, this guy, right? The unit circle allows us to understand not just angles that are not acute, but weirdo angles like 0 degrees and 90 and 180 and 270, etc. And also obtuse, reflex, this whole range of angles, right? So we redefined cos and sine as the coordinates of a point on the circumference of the circle, right? We said its coordinates will be cos, sine, okay? Given a certain angle theta at the origin, like so. Okay, so we did this, and when I did this, I sort of, on the side, mentioned to you that this line here, right, if I extended it out, so that it was not just an interval, but an actual line that would pass through the origin, okay? We noticed that if this line here, right, that height there is the y value, sine, right? And if the horizontal value here, up to this point, is cos, then in this triangle, right, rise over run is sine over cos, which is tan, right? Tan. So rise over run equals tan theta. But of course, rise over run is what we define as gradient, right? We define that as the gradient of that straight line that's passing through the origin. So in fact, I don't have to say rise over run, I can be a bit more efficient in that, and I can just say m equals tan theta. It's kind of cool, right? We've got this relationship with gradients, m, and the angles that they form with the x-axis. Okay. Now, I want to move over a little bit on this second axis. Can you see, right, that it's not that important that it passes through the origin? Okay. I can actually put this line with this gradient. I can move it anywhere I like. For instance, let's put it over here. Not passing through the origin anymore, but I can make exactly the same statement. Okay. I've got this angle theta in here, right? If I wanted to work out the equation of this line, y equals mx plus b, where can I find its gradient, right? Well, if gradient is m, that means if I go 1 unit across, let's just call that 1, okay? Then gradient means I should rise m units, right? Does that make sense? So even though this doesn't go anywhere near the origin, I can still make the same m on 1 equals tan theta statement, right? Because I still have a right angled triangle. I will always have a right angled triangle when I'm working out gradient, okay? So I can use this all the time. I'll let you think a little bit about special cases of this. For instance, this all looks nice and neat, but what if I have a line like this? What would be the implications of that? Well, how about, what if I have a line like this? Okay, think about how it relates to tan, right? If we're saying m equals tan theta. One more. This one is kind of nice. It's going up at an increasing rate. What if I said, let's move this out of the way. If I said this. Okay. Now remember, when we measure angles between lines, and the axis, we're always going with this side of the axis, right? The positive side. We go this way, and then we measure anti-clockwise, right? Well, over here, where's the angle in this case? It's obtuse, isn't it? It's there.
Oh, so you don't measure the little one.
Well, now, so again, I'm just going to give you this as the general idea, but you can see there are some special cases that kind of mean you need to be really careful with understanding this, okay? It's not that difficult, by the way. I'll just give you a really, really super fast example. If I put in this line, okay, this line, because of what it is, you might be able to anticipate what this angle is. Just think about it. Don't say it, right? How would I get that angle without knowing what it is? By using this. What's m in this case? It's -1. So I would say tan of something is equal to -1. Now, if you reached for your calculator and you said this, use this Shift Tan button, okay, it's going to tell you -45. In other words, it is actually telling you this angle, right? From which you would interpret, okay, the actual angle that I want is 135, okay? So you can't be blind with this formula, right? This formula takes advantage of a geometric structure, but there are other cases where you need to be careful with using it.